Hello everyone, welcome to Pepcoding. In this video, we will look at the question construct target array with multiple sums. Okay, so let's say I have an array 9, 3, 5. Right, I have this input and let's take another array of ones. Okay, I have an array 1, 1, 1. Now, if I have this array and I will perform some operations on this array to get this array. Right, if I can get this array by performing some operations on this array, right, if I perform some operations on this ones array and I get this array, my required array, then I will return true. Okay, else I'll return false. So let's say I have this array and I find the sum of these elements. Right, the sum of these elements is 3. So I replace one of the elements with this 3. Okay, I will get 1, 3, 1. If I decide to replace this element, right, I will get 1, 3, 1. Now 1, 3, 1. Right, now I will find the sum again and I will get 5. Right, so I replace one of the elements with this 5. I will get 1, 3 and 5. Now I will find the sum again. It will be 9. Right, I'll replace one element. I'll get 9, 3 and 5. So if I take this ones array, right, the array of ones, and I find the sum of all the elements and I replace one element with it, right, and after replacing that element I get my current answer, I get my required answer, then I can say that this is a valid answer. Okay, I hope you understand the question. Now let's take another example of 1, 1, 1, 1, 1. Okay, we're starting from here. Now our sum is going to be 5, right? So I'll replace one element. I'll get 1, 5, 1, 1, 1. Right, I'll again find the sum. It will be 9. I'll replace one element, 159, 1, 1. I'll again find the sum. It will be 17. Sum will be 159, 17, 1. Okay, let's say this was my desired array, or this was my desired vector, 159, 17, 1. Right, this approach that we used, that we took the ones array first and then we tried to find, or we tried to take the sum of every element, right, and we replaced one element with it. Next we tried to find every element, then we replaced one element with it. This is the brute force approach and it is not very optimized, right, because for every time we're making an array. So instead what we can do is we can take our array and take our vector and we can do some reverse operations, right, in constant time. If we do some reverse operations in constant time, right, and every time I replace one element, and if I get an array of ones, if I get a vector of all ones, then I can say that this is my correct answer, right, this is my valid answer. So what we are going to do is we are trying to go in reverse order, and we will try to replace one element, right, and we will try to find the solution by replacing just one element in constant time. Okay, so what we'll do is, let's discuss the approach. I will find the maximum element, right, the maximum element here is 17. Now is this 17 of some relation to the previous array, right, or the previous vector? The previous, this sum, this maximum here, I can say that this maximum will be the sum of elements of previous array or vector, sum of elements of previous vector, right, because this 17 is the sum of the previous element, right, all of the previous elements, the sum of the previous elements is this 17. So the maximum value here has to be the sum of all the elements before it. Okay, so this is my first thought process. Okay, now I've found the maximum here. Maximum is 70. Let's also find the sum. Sum will be 5 plus 9, 14, 15, 16, 33. Okay, so my sum is 33. Now if I know my sum, right, this is my sum, If I subtract this maximum from my sum, then I will get the sum of these elements, right? I will get the sum of these elements of 159 and this one, except all the elements except 17. If I want the sum of all the elements except 17, I will subtract this 17 from my sum, right? But now, see, in this array only, in this array as well, I have this 159 and this one, right? Here also I have this 159 and this one. The only element which has changed is this 17, right? The only element which has changed is this 17. From this 1 to 17, this is the only element which has changed. The rest of the elements are same. So I can say the left sum here, or the left sum here, left sum, or the sum of all the elements which are left except 17, or all the elements, the sum of all the elements except 17, the left sum here will be same as the left sum here, right? So if I can find the relation of left sum of this array and this array, then I can find the answer. Okay, so I can find this element which has changed. So what I can do is, I can see that my left sum is equals to the maximum, right? This is my maximum. So sum minus maximum, right? If I subtract this maximum from my total sum, then I will get my left sum, which is 159 and 1. If I get this left sum, now this left sum is same as this, right? 159 and 1. So if I subtract this left sum from my maximum, right? If I subtract these elements from my maximum, then I will get this element, right? Because the sum here was 70, right? The total sum here was 70. And I need to find this element, right? I need to find this element. I have this element, right? I have this element as my maximum, and I have this sum, which is this, as my left sum. So if I subtract this left sum from my maximum, then I will find this element, right? And I just need that only. So I can say that my changed val will be equal to this changed val will be equal to my maximum minus my left sum, right? If I subtract this 17, if I subtract the left sum, this left sum from my 17, then I can get this changed value, right? This is my approach. Okay, so we have this, right? But the next thing is, we know what the approach is going to be, right? I'm going to find the changed value by subtracting the left sum from my maximum. That is my case. But I just need one thing as well. That let's talk about the edge cases, right? When it is going to be false. When we say that my left sum is less than equals to 0, what does it mean? When my left sum is less than equals to 0, then it means that these values, if the sum of these values was 0, right? And if this 0, when added up with this, gave me a maximum, then this means that these values were negative, right? They were negative. So I will return false for this case. Also, if my left sum is greater than equal to my maximum, right? What does it mean? Let's say I have 1 comma 1 comma 1, right? And I replace, I will find the sum, which is 3, and I replace one element with this 3, right? I get 1 comma 1 comma 1, and I get, I have 1 comma 1 comma 1, and I get 1 comma 3 comma 1, right? This is my maximum. Now this maximum, if I take this maximum, you can see that this maximum is the sum of these elements, right? So this maximum will always be greater than every single element here, right? And this will also be greater than the sum of any number of elements here, right? Because all numbers are positive, right? They need to be positive. So this 3 should be greater than any two numbers, or any, if they were 3, if they were like this, right? Then this would have been 4. Then this 4 would have been the greater than the sum of any subsets, right? Except the whole subset, right? It would have been equal to the whole subset, but it would have been greater than every single subset beside it. Okay, so so if we have our left sum greater than my maximum, which means that this left sum, the elements this and this, right, this and this, the sum of these elements, if the sum of these elements is greater than my maximum, then it means that the element it merged with was negative, right? This element was negative. That's why it came out to be more than my maximum here, right? So I can say that if this element is also negative, I will return false in this case as well. Okay, so this is going to be my approach. I hope you understand the approach. Now let's try to code this. Okay, so the first thing is, let's take our sum, right? It is 0 and a priority queue. Now why are we using a priority queue? Because we need our maximum, right? And we can get our maximum in log n time, right? So we'll use a priority queue for that. We need to find our maximum in some optimized way, right? Don't need to traverse the array every time. So pq.push, let's convert the element as well because our priority queue is of long type, right? Now my sum will be sum equals to element. After this, I just need to run a loop, right? While pq.top is not equals to 1. This means that my maximum element till here is not equals to 1, right? If now I'll find the maximum element, which is pq.top, right? I'll remove the maximum element, then my sum will be, now this is my left sum, right? My left sum is the total sum minus my top, right? So I can say that this is my left sum as well, but I'm just taking the sum only. Now if sum is less than equals to 0 or sum is greater than equals to top, then I'll return false for that case, right? Now if my new top will be top minus sum and sum will be plus equals to top, right? Also I have to push this element, so if top is greater than 0, then only I'm going to push top, else I'm going to push sum, right? And if this while loop runs completely fine, then I'll return true in that case. Okay, so this is my code, but there is a problem here in this top equals to top minus 1, top equals to top minus sum. Okay, so let's see. Let's say that I have a array 1 comma 1 comma 1, right? And I change this array to I get my sum, I get 3, right? So I replace this element, this 1 here, with this 3. So I get 1 comma 3 comma 1. Then I take the sum again, it is 5. I replace this 3 only, I get 1 comma 5 comma 1, right? I can take the sum again, 7, 1 comma 7 comma 1, right? Take the sum again, 9, 1 comma 9 comma 1. Take the sum again, 11, 1 comma 11 comma 1. So let's say this was my desired array, right? 1 comma 11 comma 1 was my desired array. But if I need to go back, I have to do the same thing every time, right? I have to I'm checking that I'm just changing the value by 2 only every single time, right? And then if this is the case, then I can simply just jump here, right? I can simply jump here by not doing top minus sum, but I can do top equals to top modulo sum, right? I can find the modulo and I can just simply go directly here instead of going in stepwise motion, right? So instead of top equals to top minus sum, I can write top equals to modulo sum. Okay, this looks fine. Now let's try to run this code. It's successful. Let's submit this. It has passed all the test cases. So I hope you understand this question. If you don't, I would suggest you watch the part which you don't understand. Don't forget to like, share, and subscribe. Thank you for watching.